Hello everyone, welcome to Skill Dev. Trey here, and in this lesson, we're going to learn about pointers. When we use the term pointer, we just mean we're referencing a location in memory. That's a very simple and low-level definition, but for our interview questions, we're going to be forming data structures where each item in the data structure is its own object, and the way you get from one item to another, or one node, which is an object, to the next node, is a reference to that next item. So there will be a next pointer, which is a reference to the next item in the data structure. So for this lesson, we're going to keep it language agnostic and try to keep it high level, and really focus on the concepts we're going to need for interviews. So with that in mind, let's learn what it actually means to use a pointer in memory. So let's say we declare the variable myObj. It declares it at this memory address, and then the value is the memory address of the object itself. So it's a hexadecimal value, and it's a pointer to where the object is stored in memory. So going by the definition, a pointer is a reference to a location in memory. And that's all we mean. So now let's dive into that a little deeper. Pointers are a fundamental concept in computer science, and it's how we deal with items that we store in memory. Let's imagine this is how our computer's memory looks. We have memory in the stack, and we have memory for the heap. For this high-level example, we're just going to assume that primitives are declared on the stack, and then we store non-primitives like objects in the heap. So if we declare the two variables isValid and secret to life, they're both primitives. So we create a memory address and then store their primitive value in the stack. But now we want to declare an object. We use a new memory address, and then the value is an integer in hexadecimal form that points to the location of that object in the heap. So it's a pointer to the actual data. So here in JavaScript, when we declare an object using object literal syntax, we're actually just creating a reference to that object in memory. So the value actually stored in the variable just tells us where to find the object that was created and stored in the heap. Now let's say we create another object. Another object equals myObj. So what we've done is set this object's value to the same memory location. So they have a pointer to the same memory address where this object is stored. So now on another obj, we set its A property to 987. We see the object itself changed in memory, and since these items are pointing to the same object, if we log this property on myObj, it would also be changed. Because each item stored in these variables is the same memory location, which is a pointer to this object in memory, by changing the object, we're going to see the change in both variables because the variables themselves just have a pointer to the same memory slot. But now for another obj, let's set it equal to a new object. Since it's a new object, we use a new memory slot in the heap and initialize a new object. So now another obj has its pointer or its reference to memory to this new item. This had no effect on myObj because this hasn't been changed. It's still referencing the old object. If we set myObject to another object, now they're both referencing the same memory location again, and neither is pointing to the old one. So in many languages, when our code is no longer referencing an object, it's going to be cleared in a process called garbage collection. In some lower level languages, like C, you actually need to manage this yourself, and if you're ever done using an object or a variable, you actually have to delete it from memory. So this is going to be language specific, but many higher level languages handle this for you. And now if we set my object to null, it's nulled out this value, and once again, it didn't change another object. It's still just referencing the same location in memory. It just changed the value that we had stored in this variable. So with that in mind, let's go back to our initial example, because this is what we're really going to be using in our interviews. So if we set a next value, all we're doing is pointing to the next item in the data structure, which is just going to reference that object in memory. So if we declared my object, it's going to create an object in the heap, and the variable is going to point to that object. Then for its next value, it's just going to point to that next object in the data structure. So it points to that memory location to create this chain of nodes. Then this object's next pointer is going to point to the next item. And then finally, this last object points its next to null, so the data structure itself is done. Another important concept when discussing pointers is pass by value and pass by reference. Once again, we're going to keep it high level just to understand the concept, but we're going to have two functions, and we're going to be using JavaScript as the example. So for primitives, they're always passed by value. So if we have this function pass by value, we declare the variable value, which is 42. When we call pass by value and pass it in this variable, we set val equal to 5, but it doesn't change the original variable. So this creates a new variable inside this function that has the same value originally. So it starts out as 42. This value is set to 5 inside the function, but it has no impact on the original variable that we declared. But if we pass an object to a function, it's actually passing that reference to the object in memory. So if we declare an object, call pass by reference, and then in this function, change one of the object's attributes, it's actually referencing that object in memory because there's a pointer to that object. So the object itself is being changed. So it's not being passed by value, it's passing the reference of the object itself, which means it changes the original object. So if we print the value of this object after we call this function, its name goes from test to iChanged. So with pass by value, you create a copy of the value into a new variable in the function. When you pass by reference, you're actually passing the original object or a reference to that object in memory, so you can change the object itself. It's not creating a new object in a new variable, it's the original object. So for interviews, and really in this course, when we're talking about pointers, most often we're just talking about creating these data structures where each individual object is a node, and then you reference another object or point to it in one of its attributes. And this is how you form the data structure. Another important concept is pass by reference and pass by value. You really just need to know that reference is going to change the original variable or the data stored in it, but when you pass by value, it's just creating a copy of that original variable and won't have any impact on the item originally declared. And finally, each language is going to handle pointers slightly differently. For higher level languages, this isn't much of a concern. Much of this is handled underneath the hood, and you just need to know if an object is ever passed by reference or passed by value. For those compiled and lower level languages, sometimes you need to manage this yourself. You need to reference pointers, dereference pointers, and more thoroughly know when each is being handled, and also possibly garbage collect it. So if it's your language of choice, it's important to know this before going into your interviews. Thanks everyone, and I'll see you in the next lesson.